It's the only one of the 7 wonders of the world that is still standing today. 5 million tons of stone, stacked 146 meters high, 4,500 years ago. The Great Pyramid of Khufu is the tallest, largest, and most enigmatic of all the pharaonic constructions. 45 centuries later, the mystery lives on. How was the pyramid actually built? French architect Jean-Pierre Houdin has been investigating this question for 10 years. He's scrutinized and studied the monument with the eye of an expert, as if he were going to rebuild the whole thing himself. Today, at the end of his investigations, and with the help of new technology, he's offering a revolutionary solution. Could he have managed to solve the mystery of the Great Pyramid of Khufu? To understand the mystery of the pyramids, we need to go back in time to the era when Egypt built these enormous tombs. On the Giza Plateau, these mountains of stone are the masterpieces of a civilization wholeheartedly committed to the quest for eternity. Pyramids were the sacred gateways that let kings pass through to the land of immortal life after death. The Egyptians built the finest and most impressive of them in a single century at the close of the prehistoric era. The first ones were step pyramids, like the Pyramid of Djoser at Saqqara. After the 26th century BC, the first true smooth-sided pyramids were the work of a single family headed by Snefru, who was the father of Khufu and grandfather of Khephren. Originally, the outer surface of the tombs was made of a smooth layer of dazzling white limestone blocks. Pyramids were the earthly incarnation of the sun's rays. As time went by, these outer stones got pillaged in order to build palaces, temples, and mosques. Khufu still has a few left at its base, and Khephren has managed to keep its original stone layer at the top. Khephren was the last monumental pyramid that Egypt built. This period of amazing technological progress only lasted a century. Not long after, Egypt underwent serious climate changes. The country was plagued by drought and ravaged by civil wars, invasions, and social strife. The secrets of the pyramid's construction got lost during these tumultuous times. Recently, archaeologists have discovered the village that housed the workers who built these monuments 4,500 years ago. Egyptologists have unearthed numerous clues into their way of life. They were well-fed and decently housed. They were given meat, beer, and bread. The excavations have even shown that the workers were not slaves, as it was once believed. They were proud to serve their pharaoh and accompany him on his journey to the afterlife. But none of this fascinating research yielded any new information about the methods used to build the pyramids, especially not for the biggest and most complex of them all, Khufu. Towering at 146 meters, it was the tallest man-made structure ever built until the end of the 19th century. Khufu is also the only pyramid with a granite chamber tucked away at its heart, with beams weighing over 60 tons, a genuine challenge within the challenge. The pyramid's staggering height and this granite chamber are the two key mysteries surrounding Khufu's construction. Nobody, until now, has ever solved this riddle written in stone. Still, many theories have been put forward. In the 5th century BC, the Greek historian Herodotus suggested the use of wooden levers. Egyptologists then imagined massive ramps leading up to the summit, or else an external spiral ramp. But in the end, these theories, which we find in every historical reference book, have never been very convincing. Today, an architect claims to have solved the mystery. If he's right, it will turn out to be the most important discovery since Tutankhamun's tomb was found. Jean-Pierre Houdin's story begins in January 1999. He'd taken a year off to get some perspective on his life and was looking for a new challenge. Then one day, his father sent him a tape of a film he'd seen on TV about the mysteries of the pyramids. The documentary explored the different theories of how the pyramids were built, but not one of them was credible. His father, a former public works engineer, got caught up in the mystery and imagined a solution. The pyramid could have been built from the inside with the help of a circular tunnel. Naturally, Henri Houdin shared the idea with his architect's son.
That your idea for an internal ramp? Intriguing. I will have a look at your drawing and call you back later.
Jean-Pierre was fascinated and devoured anything he could get his hands on concerning the pyramids. He read the most reputable books, studied every drawing, and analyzed every theory. Almost overnight, he became a fanatical expert on the architectural wonders of ancient Egypt. A simple architect was transformed into an obsessional genius. He threw himself 100% into his research. He closed his architecture firm and sold his apartment to move into a small family studio. He worked 10 hours a day developing his father's idea, adapting it in keeping with the ancient Egyptians' know-how.
So your ramp is here. See, it's basically a great idea. But I think we should break it up into sections, like this.
Seems logical.
A spiral with right angles. And see, it goes up like this.
Well, all you have to do is keep working on it.
Well, I think it might take about 10 years before I can get you onto the internal ramp. There is a lot of work to do.
The Egyptians didn't know how to build circular tunnels. On the other hand, they knew how to make right-angled galleries. Jean-Pierre patiently developed his idea of an internal ramp. His ramp would enable limestone blocks to be hauled to the very top, 146 meters up. He believed the ramp would never have more than a 7% incline, because otherwise it would be too steep for dragging up the stones. Notches at each right angle would allow the stones to be turned and also provide ventilation for the tunnels. It was a brilliant theory, revolutionary even, but it still had to be proven. It was time for Jean-Pierre to shift into high gear, but for that, he needed to convince the learned specialists and top experts. He spent several months contacting various Egyptologists, but no one bothered to reply. They were sick and tired of receiving yet another new theory about the pyramids. They didn't even bother to look at his dossier. Jean-Pierre didn't belong to the club. He was nothing but an outsider. And yet, the pyramid's construction is definitely an architect's business, at least as much, if not more so, than Egyptologists. No one's a prophet in their own land. After trying his luck with French scientists, Jean-Pierre set his sights on the U.S. In New York, one renowned Egyptologist finally agreed to meet him. Jean-Pierre pulled out his last playing card. To get to Egypt and verify his theory, Jean-Pierre needed an in. Bob Breyer looked like he might be the man, the key that would move his investigation forward.
Welcome to the Bronx.
Thank you.
Come on in, come on in. When he opened his laptop, there were several of us in my apartment, and we all gathered around the laptop to see what he had. And he had these beautiful, beautiful diagrams of the pyramid, things I had never seen. He had created them on the laptop, and he started explaining his theory.
The architect presented his revolutionary idea. The pyramid could have been built from the inside out.
Okay. So there's a ramp inside the pyramid.
Ramp inside.
Is it still there?
Still there, yes. And now?
I thought the theory was incredible. I wasn't sure. You know, there are other theories about the pyramid, but they all have problems. This theory solved some of those problems, but it was just so amazing that I just couldn't believe it could be true at first. So what did you think the first time you saw the pyramid?
The first time I saw the pyramid.
Yeah.
Let me tell you, Bob, I never went to the pyramid. Never.
You never saw it?
No.
You've been working on this thing for 5 years, and you haven't seen the pyramid? No. No?
No.
Why not?
Because I think it's intellectual work. It's something. I think also that I am completely free. It's a concept.
Yes.
At the base, the architect who draw the pyramid have no pyramid in front of them.
Look, if anybody's going to take your theory seriously, you have to see the pyramid.
Bob Breyer was hooked by the story and Jean-Pierre's theory. He decided to help him and convinced him to finally go to Egypt. Finally, 5 years after he began his investigation, Jean-Pierre Houdin discovered the pyramids.
It wasn't like I got there and went, whoa, there's a pyramid. I was impressed, like everyone, but I was already so familiar with it. I knew it inside and out. I saw it in a different way. I knew where every little stone was, every little detail, every little drawing. I felt at home.
Thanks to Bob Breyer, he enjoyed the rare privilege of a private tour.
We are in the Thieves' entrance. This is where tourists come in now. This entrance was opened up by the Caliph Mamun around 850 AD to rob the pyramid. The real entrance is about 7 meters east of this corridor. If we keep going, we will arrive at a corridor that leads up to the Grand Gallery and the King's Chamber.
But Jean-Pierre is not a tourist. He's looking for clues. In the heart of the pharaonic structure, his priority is to find evidence to back his theory. He's intrigued by a number of details. These regularly spaced rectangular holes, and these chisel marks all along the Grand Gallery. Finally, he reaches the King's Chamber, made entirely out of granite. Gigantic beams above him, weighing about 60 tons apiece, form a flat ceiling. An aberration for the time, considering the thousands of tons of stone piled above it. The chamber is a real architectural feat. He admires the joints between the stones. They're perfect. Not even a razor blade could slip into the cracks. How did the Egyptians manage to transport stone blocks of this size into the heart of the pyramid? Jean-Pierre's internal ramp doesn't solve this problem. It is the second riddle of the Great Pyramid he needs to tackle. At the top of the Grand Gallery, there's a narrow passage leading above the king's chamber. It gives access to 5 stories of granite beams called relieving chambers. These are topped with an enormous gabled limestone roof. The blocks alleviate the weight pressing down on the roof of the funeral chamber. Without this ingenious system, the ceiling of the king's chamber and the Grand Gallery would have collapsed. But the granite beams suffered some cracks during construction. To check the extent of the damage, the Khufu builders opened up this passage that leads straight to the heart of the brilliant architectural system. Among the graffiti scrawled by unscrupulous visitors, Jean-Pierre looks for the cartouche of Pharaoh Khufu, first discovered at the beginning of the 19th century.
This proves that it's really Khufu's pyramid. It means Phnom Khufu. We are in the heart of the pyramid. It's absolutely incredible. And there are hundreds of thousands of tons right above our heads. And it's all held up by these beams. And it's been here for 45 centuries. You can just feel how calm it is. The serenity is pretty moving, isn't it?
At the Egyptian Museum in Cairo, the treasures of the pharaohs are on display. Millions of pieces chronicle the prestigious history of one of humanity's most brilliant civilizations. But paradoxically, only 2 elements are directly linked to the Great Pyramid. Today, Jean-Pierre has an appointment with the man who designed and built the greatest pyramid of all times. Ironically, the only image of Khufu that has survived is just a few centimeters tall, a minuscule ivory figurine discovered by chance in a temple in 1903. Despite the absence of monumental statues or bas-reliefs, Khufu's memory is still very much alive. An enigmatic sphinx, he continues to intrigue the entire world with the mystery of how his pyramid was built. Jean-Pierre also wants to see what he considers one of the greatest treasures at the Cairo Museum, a 4,500-year-old cedar wood sled. Most visitors hardly pay any attention to what seems like some plain, everyday object. Yet, it's a unique piece that offers insight into the pyramid's construction.
Wood was like gold for the Egyptians. It cost a fortune to bring wood from Lebanon, so they use it up to the end.
Back in Khufu's days, the Egyptians didn't know about the wheel. They used these cedar sleds to haul stone blocks. Considering the tools available to them, the Egyptians accomplished amazing technical feats. Their monumental constructions have weathered thousands of years. They bear witness to the genius of these men from antiquity and continue to fascinate Egyptologists and architects today. Bob Breyer is convinced of the importance of Jean-Pierre's theory. He joins him in Cairo to help him find new clues and evidence.
No, just a mint tea.
واحد معايا ممكن واحد شاي بنانا شكرا
To prepare for their expedition the next day, they begin by taking stock of some of the building's theories other people have come up with. Most involve some kind of ramp, but have major flaws, according to the architect.
Either it's too steep.
Yeah, that's a big problem with these ramps.
It's a huge problem. Either it's too steep or it's too long, and then it causes a quarry.
Because it's too high.
It has to be 1.6 kilometers, and then the ramp would be bigger than the pyramid itself. This one is really steep, good for ski jumps or for the Olympics. It's fine for that.
Tell me, what's this?
Ça, c'est HIV virus. Maybe? Celle-là, elle est
This one is interesting.
Oui, parce que, enfin, c'est intéressant.
Yes, because the 1.6 kilometers are not in front of the pyramid, but all around it.
On les a autour.
This type of external spiral ramp around the pyramid raises a number of questions. How could such a ramp be attached to a smooth-sided pyramid? How do you turn a corner with 600 men, considering that's how many people you needed to pull a 60-ton granite block? Besides, with this type of external ramp, you couldn't check the geometry during construction. If the edges weren't perfectly aligned and controlled, the pyramid could end up twisted.
Great.
For these reasons, Jean-Pierre's theory suggests there were two ramps. First, an external ramp that only went 43 meters high. This would have allowed the first two-thirds of the pyramid's total volume to be put in place, as well as the granite blocks for the king's chamber. In addition to this, the Egyptians would have built a second ramp inside the pyramid. This system offers a solution to the two key problems the Khufu pyramid presented: its height, 146 meters, and its unique granite chamber. Once they reached the critical level of 43 meters, and the granite blocks had been brought up for the king's chamber, the Egyptians would have dismantled the first ramp and recycled the blocks it was made of, hauling them up the internal ramp to finish the pyramid. Nothing would have been wasted. Now the theory needs to be proven. They need to find evidence of his internal ramp. Bob has an idea. "15 kilometers south of Cairo, the Egyptologist takes Jean-Pierre to the ruins of a temple that was dedicated to the sun, built 100 years after Khufu. The temple was destroyed at the end of the 19th century, but an architect's drawing of it still exists. On the drawing, we can see that the temple had a corridor similar to Jean-Pierre's internal ramp. Our two investigators want to see for themselves what's left of it.
But I think we should be able to imagine the ramp.
Well, you don't have to imagine it, Jean-Pierre.
Yes. Oh.
Is it an internal ramp?
Yes, it is an internal ramp.
Oui.
Oh, c'est...
Certainement?
Oh.
You're sure?
That is for sure.
Oui.
It's the first U-turn, yes.
Yes, we go here.
It's a quarter-turn ramp like mine.
Yes, let me show you something up here. Come on. You're going to like it. Now, this block for the ceiling, right?
Yes.
The plafond?
Yeah, of
Oui.
course.
Oui. Color the blue for the ciel, for the sky, right? And there are stars here. You see them? Right there. There's a little circle, and it radiates out.
Oh, you have a lot of stars.
Yes, all over the block. So this was the ceiling block for the internal ramp. Look at the diagram, though. Let's just see what we can figure out. So we came up the ramp here,
Yes.
and we made the turn here,
Yes.
right? And this block, what do you think?
I suppose
Que penses?
maybe it's this one, or maybe it's this one.
So this block could be
Yes.
either here or here, this ceiling block.
Yes.
So it's definitely internal ramp, right?
Yes, it is, definitively.
These remains of an internal ramp prove that the ancient Egyptians knew how to build this type of corridor at the time of Khufu, an important step towards confirming the architect's hypothesis. But the demonstration isn't over yet. Another important aspect of Jean-Pierre's theory can also be tested out in the field. He believes that to form a perfect pyramid, the Egyptians must have laid the outer surface blocks first rather than last, like many previous theories claim. This would have allowed the overall form and angles of the pyramid to be monitored throughout construction. To understand this principle, they need to make a trip to Dashur, about 30 kilometers south of Cairo. Jean-Pierre and Bob are particularly interested in these magnificent casing stones. The outer layer is made of white limestone blocks that weigh between 4 and 5 tons and are up to 2 meters thick, twice as big as the stones positioned behind them. Architecturally speaking, this is a fact of major importance.
They broke the casing stone over, already dressed, and put it in place on this block. And after they kept on, it's like that all the way to the top.
Got it. So these had to be put in smooth, right from the beginning, bottom up.
It's a concrete evidence that the casing is done as the pyramid rises, and the outside of the pyramid is finished first.
The casing stones would have had to be laid first, allowing the geometry of the pyramid to be monitored as the building advanced. Next, the Egyptians would have positioned the second row of well-hewn stones, followed by rougher blocks of various sizes that acted as a kind of filler. This would have allowed them to work faster and finish building in about 20 years, like it is mentioned in ancient Egyptian manuscripts. The clues Jean-Pierre has gathered out in the field are encouraging for the investigation, but he wants to find proof that the internal ramp actually existed.
You can see two whitish lines about 2/3 up.
Oddly enough, these phantom lines reflect the exact position of the internal ramp with the same 7% slope.
Is the pyramid breathing? Is it an optical illusion or a thermal phenomenon? It's pretty strange.
In order to detect the internal ramp, the pyramid would have to be scanned. The different densities inside it would need to be measured. This would provide physical and therefore undeniable scientific proof of the ramp's existence. Actually, a similar study was already done in 1986. Back at the time, a team of French engineers analyzed the Khufu pyramid using a technique called microgravimetry. This method allows us to see minor variations in mass and density. In fact, it involves detecting what scientists call zones of significant subdensity, in other words, empty spaces. For months, the technicians took thousands of measurements, both inside and outside the pyramid. The team wasn't interested in figuring out how it was built. They were hoping to find a secret chamber. In this respect, their mission was a total failure. Scientific publications of their study went completely unnoticed. Yet, without realizing it, these engineers may have found the scientific proof that Jean-Pierre Houdin has been looking for so many years. Jean-Pierre contacted one of the scientists who worked on the mission. Huy Dongbui is a member of the French Science Academy and École Polytechnique, France's equivalent of MIT.
We found that the subdensity, the density deficits, formed something that was like a spiral.
A spiral shape?
Exactly.
A spiral shape, but in subdensity?
Right, in subdensity. The white and green show the subdensity zones.
Subdensity?
It was drawn by hand. My colleague did it.
We really see the spiral.
We see the spiral, the subdensity zone, in white.
The microgravimetric study shows that in relation to the pyramid's volume, 15% of its mass is missing. The empty spaces inside the monument seem to form a spiral. Back in 1986, Louis Dongbui and his colleagues didn't know what to make of this startling discovery. Now, in light of Jean-Pierre Houdin's theory of the internal ramp, the study makes sense. Microgravimetry offers the scientific proof the architect needed. This irrefutable element convinces Jean-Pierre to devote his life to solving the mystery of how the Great Pyramid of Khufu was built. Jean-Pierre Houdin is now firmly convinced that the internal ramp is definitely there, just a few meters behind these blocks of stone. But he's now looking for more proof that the ramp really exists. If we continue along the phantom lines we'd seen before, we come to something that absolutely fascinates him. According to his calculations, this hole, located at the northeast angle of the pyramid, lies directly on the path of the internal ramp. Would this be what remains from one of the notches that allowed the Egyptians to turn the stone blocks? They'll need to take a closer look, but climbing the pyramid is prohibited. It's dangerous, and many tourists have already suffered accidents.
Look at the shape of this notch.
Okay.
The pavement,
Okay.
the walls,
Yes. And take plenty of pictures.
plenty of pictures.
Okay.
And come back safe.
It's a deal. Okay.
Okay.
Take care.
That being said, the Egyptian authorities are willing to make an exception for certain Egyptologists. Along with a cameraman who's an excellent mountain climber, Bob Breyer is going to check out what the notch looks like up close.
We're getting there. Slowly but surely we're getting there. Whoa. Ah. Whoa. C'est noir.
Oh, it's really dark.
Bob wasn't expecting this dark space. He hasn't even brought a flashlight powerful enough to light it.
I think this is interesting. It's not the internal ramp, but it's still very interesting. Why is the space so big? Photos. Photos for Jean-Pierre.
The space wasn't carved out from the stone. It visibly dates back to the pyramid's construction. There's no description of it in any Egyptological book. Up till now, no one has ever investigated this architectural curiosity. Could the existence of this unanticipated room be further evidence of an internal ramp, one that's still there?
Let me see if I feel any air coming out. No, it's not like a breeze or anything like that, so I don't know how far it goes. It's not exactly an internal ramp, but it's a big space. I think Jean-Pierre will be interested. I really don't know what it's for. Maybe it's just an accident to construction. Maybe it's not. He'll know better than me. Whew. Better.
Back at the hotel, Jean-Pierre studies Bob's photos. Then he checks the plans of the pyramid to see whether there's any drawing or description of the empty space behind the notch anywhere. Even if he knows there isn't. He's sorry he couldn't see it for himself. Jean-Pierre feels he is so close and yet still so far from solving the mystery. However, Jean-Pierre does have a certain number of elements to confirm his theory. The casing stones were definitely placed first. This rules out the possibility of an external spiral ramp, since there's no way it could have been attached to the smooth surface. The Temple of Nusirere proves that the ancient Egyptians knew how to build an internal ramp. The phantom lines, with their 7% slope, are definitely intriguing. The microgravimetric results offer undeniable proof that empty spaces in the spiral form, like his ramp, actually exist within the pyramid. And finally, there's this hollow space Bob discovered behind the notch. Although all these elements are convincing, another enigma remains at the very heart of the pyramid, the king's chamber. The theory of the internal ramp works very well for moving limestone blocks that weigh about 2 tons on average. But how did the ancient workers manage to haul up the granite stones that were so much heavier? This is the most remarkable aspect of the investigation and the most complex to figure out.
The one part I'm really not sure about that really is the Grand Gallery. This idea that the Grand Gallery was somehow used to raise the blocks to the very top. It's interesting. It's the most interesting explanation of the Grand Gallery anybody's ever come up with. But I'm really not sure.
The external ramp that Jean-Pierre imagines isn't enough to explain how the huge granite blocks were moved into the heart of the pyramid. On a ramp with a 7% incline, you'd need 600 men to haul a 60-ton block, but coordinating so many men would be an impossible task. Jean-Pierre thinks the key to the mystery is the Grand Gallery itself. He's convinced the gallery was the key element of a gigantic system of counterweights that would have made it possible for just 100 men to move the enormous granite blocks. The Grand Gallery is truly an impressive structure. 8 meters high, 48 meters long, and a 50% rate of incline, it has fascinated everyone who's ever entered it. The layout makes no sense from a ceremonial point of view. Could it have been built for practical reasons? If Jean-Pierre's hunch turns out to be right, it'll be a total revolution for Egyptology. The stakes are high. So Bob has some very specific questions for the architect.
Jean-Pierre, you are the man with the theory. You've got a lot of things to explain. First, what are these benches?
On this bench, you had rollers.
Are these logs?
Logs, yes.
Okay, yes, go ahead.
And these logs, on these logs,
yes,
you have a trolley.
Yes.
For the counterweight system.
Okay, so the trolley runs up and down on logs, which are across the 2 benches.
Across the 2 benches.
Okay, now I got another question. There are like 28 of these slots. They're important, obviously. It's the first thing you see. What's going on?
In these slots, you had wooden beams.
Yes. What are they doing?
Holding the rollers, keeping the rollers.
So these rollers are like logs going on a bench. You got the trolley on top of it, and you got beams in here making sure the logs don't go wild. Jean-Pierre, I understand the rollers rolling, the weights are sliding, but is there any evidence that this room was actually used?
I think if you have a closer look to the bench, on the vertical fence, we will find some grease, some scratch left by the roller stripe.
This thing that looks like a racing stripe on a car?
Yes, look right,
yeah,
right
it's
there.
Clear.
Yes,
it's a brown stripe going down. That's grease, you think?
It's all along the bench.
Yes, yes, yes.
It's the same mark.
So the trolley, when it goes up and down, they had to lubricate it. They put grease,
yes.
And then by going up and down, it
And
scratches?
sometimes the trolley was
shaking a bit?
Shaking a bit.
Uh-huh.
Just a small stone and scratch.
No, pretty good. It looks like it was used.
And it's completely parallel to the bench.
No, that's good. Good.
There is something more. Look at the third cobbling. Look this groove.
Yeah, yeah, it runs the whole way.
All the way on the gallery, on both sides.
Well, what was it used for?
I think it was used to hold another beam, wooden beam,
right,
on which the trolley was sliding on.
For the ancient Egyptians, wood was scarce and very precious. According to Jean-Pierre, they would have recovered the wooden beams when the pyramid was completed, which explains the chisel marks.
You know, I've been here 50 times and I never noticed that. It goes the whole length. That's terrific. So it's another evidence that the thing was really used for a trolley sliding up and down, and that's the stabilizer.
It's too much details.
Okay.
Understand?
Yes.
Too much details.
A lot of details.
There's another clue at the top of the gallery. Though this step has been cemented, it was originally chiseled in a V shape, maybe to facilitate the sliding of ropes. Jean-Pierre could be right, but has he convinced the Egyptologist?
It just seems so incredible that they built this fabulous room, this grand gallery, just to raise the blocks up to the top. But it could be.
For the time being, the on-site investigation is over. But Jean-Pierre hopes to go further now. Back in Paris, he's contacted by an engineer who tells him about a sponsorship program called Passion for Innovation. The obsessional genius is about to strike again.
Do you really feel like you're walking in Shenzhen?
Oh, yeah, I'm totally in it. But we need to adjust the sensor for the lateral position.
Sure, those are the little adjustments we needed first. Oh, hey, Jean-Pierre. Hello, how are you? Mehdi, this is Jean-Pierre Houdin, the architect I was telling you about, with a new theory on Khufu.
Oh, right, great. Richard told me all about it. Mehdi Tayoubi, nice to meet you.
What are you doing in there?
Well, it's actually a simulator that lets you walk in virtual reality. It was summer 2005. At the time, I admit I didn't know the construction of Khufu was still a mystery. Then he got me all caught up in it. What I liked about Jean-Pierre was mainly his enthusiasm and the fact he was an outsider who decided to tackle one of humanity's oldest mysteries and wasn't afraid to do it. Don't you think we could simulate all that?
Sure we could.
Yes, well, I did this by myself.
Right, we'll shift into high gear.
For starters, we can make a 3D model, no problem.
No reason we can do it for a plane or a car, not for a pyramid.
Dassault Systems develops scientific 3D software to design and visualize the finest industrial projects of the future. With these innovative tools, an industrial project can be entirely simulated before making it happen in the real world. From design to engineering to the most unusual architectural projects. The software applications are like virtual labs where the coherence and feasibility of what inventors have come up with get tested out.
Hi guys.
How's it going, Jean-Pierre?
So, after several years of working alone, suddenly, Jean-Pierre finds himself surrounded by an enthusiastic team of engineers. For 2 years, they worked on modeling the pyramid and how it was built using their own 3D scientific tools.
There were several stages. First, we modeled the wall of the external ramp and then part of the pyramid.
The engineers entered all the geometric and physical characteristics into the computer, and they put Jean-Pierre's ideas to the test.
Through simulation, we can show everything works correctly.
20 machines like that, it's absolutely possible. Richard, where do you stand?
Their expertise has even allowed them to explain why the granite beams in the king's chamber cracked, a mystery which, in terms of Egyptology, has caused much speculation up until the present scientific analysis. Step by step, they calculated the combined weight on the beams, the limestone rafters, then the 83 meters of stonework above that. No cracks appeared. Finally, they added one last factor: a 3-centimeter shift of the southern wall of the king's chamber.
With the pyramid completed, look, we lower the southern side, the rafters open up, and look here, on the first 3 ceilings, red, red, red. Red means we're at the granite's breaking point.
The engineers also studied the system of counterweights.
The counterweight goes down, the beam goes up, and the little arrow, what is it?
Oh, that's the force supplied by manpower.
So the force is the number of men.
We didn't find anything impossible about Jean-Pierre's theory. We're not saying that's how it happened because we weren't there to see it, but we can say that it very well could have happened like that. Mechanically speaking, it's realistic. It holds up.
Could Jean-Pierre Houdin have proven his hypothesis? In any case, his theory is the first and only to be confirmed by scientific 3D methods. It is now possible to rebuild Khufu step by step. Nobody has ever gotten this far before. Jean-Pierre also manages to explain the photos Bob took of the notch.
Jean-Pierre, why don't you send us the pictures Bob took there, and Jacques will get the simulation going to see if the reality matches the virtual. Okay?
We will get a better idea of what we are seeing.
You recreated all the stones?
Based on the video image, shot by shot, we recreated all the blocks. Bob got special permission to climb up into the notch. I told him to take measurements and to look into the holes.
He wasn't expecting to find the room?
No, and he found a 9-meter square room.
And you're saying until now no one's ever described this room? There's no data?
No. After that, we even did research, but we didn't find anything. So now, you see, we cut the pyramid in slices, like a ham, and we go down layer by layer. Here, stop. See, there are ramps. That's the top of the corbelling.
For them, the internal ramp is behind the walls of this room.
See, Mehdi, behind this stone. Jacques, can you remove that stone? What do we have? The internal ramp.
You mean you didn't have an endoscopic camera to go in?
We didn't expect that. It's the kind of thing you feel bad about.
It's just right there.
But you know, there should be leaks. With a thermal camera, we could see the leaks between the stones. The air coming out would be cooler than the air in the room.
So you're saying all you need is permission to go back into the room with a thermal camera and put it right in front of those 2 blocks, and then we'd see there's an internal ramp behind them?
If we have the green light to go back, we will prove that the internal ramp is there.
To solve the mystery, all they need now is an authorization. If Jean-Pierre is right, as everything seems to indicate, the discovery will cause a huge stir. How much longer will he have to wait? Nobody knows. But he's already been working on this project for 10 years. He's not afraid of waiting a little longer. When it comes to pyramids, the notion of time is all relative. Meanwhile, he decided to share his theory with the world. The news has circled the entire globe.
Un arquitecto francés cree haber descubierto la respuesta a una viejísima.
And now a French architect claims to have finally unlocked the secret.
It's better than the other theories because this is the only one which works.
La missione del noto architetto francese Jean-Pierre Houdin è stata quella di provare a risolvere l'enigma che si cela nel muro della piramide di Cheops.
Jean-Pierre Houdin's investigation is over, but the story isn't. In the meantime, our architect visits the tomb of his predecessor, Hemiunu, the man who built Khufu's pyramid 4,500 years ago. He wants to pay homage one last time to the unbelievable genius of the great ancient builders before one day climbing the pyramid himself along the internal ramp.
A French architect has discovered the existence of two previously unknown rooms in the Pyramid of Khufu. He announced his discovery in Paris on Thursday, saying that he noticed that one stone element in the burial room was not supporting any weight and therefore had once been a passage. Before now, no one had suspected the existence of any such room. Let's find out more.
According to funeral rites of ancient Egypt, kings would be buried with all their belongings in close vicinity. It was a belief that the dead needed all the comforts they had during life, such as a chair, table, or a bed, items that in other pyramids are situated in an adjacent room to the burial room. After unveiling his hypothesis at a presentation using 3D computer simulation, Houdin announced his finds.
We unveiled, that inside the Khufu pyramid there are two antechambers that are part of the Khufu funeral apartments. They were unknown and are very close to the king's chamber.
The current entrance that visitors use today was opened in 820 AD by Caliph al-Ma'mun in his speech for Khufu treasure. But he didn't find much, and little did he know that the real entrance to the king's chamber was right under his nose.
History stops at this event, saying that the robber entered through the door, went all the way to the king's chamber, and left. History was not completed because Mammon got the wrong corridor. The corridor and the antechambers are just behind. Now we need to go and find them, but it's not difficult now to find them.
Jean-Pierre Houdin is the same man who in 2007 believed he cracked the 4,500-year-old mystery surrounding Egypt's Great Pyramid, saying it was built from the inside out. Previous theories suggest that Pharaoh Khufu's tomb was built using either a vast frontal ramp or a ramp in a corkscrew shape around the exterior to haul up the stonework. To prove his case, Houdin teamed up with a French company that builds 3D models for auto and airplane design. Now, to prove his theory, an international team will probe the pyramid using radar and heat-detecting cameras after consent from Egyptian authorities. Li Xiang, CCTV.